Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem median in a row-wise sorted matrix. So in the problem statement we are just given a row-wise sorted matrix of size n cross m where the number of rows and columns is always odd and we have to return the median of the matrix. So we can see in the example also that as input we are given matrix, a 2D matrix of n cross m size. Here in the example 1 I have taken this matrix uh, as example. So this is my example 1. All right, so now what I have to do, that I have to find the median of the matrix, and all the rows we can see that first row, second row, third row, these all rows are sorted. All right, these all rows are sorted, but the entire matrix is not sorted, just the rows are sorted. All right, now we have to find the median of the matrix. So how can we find the median of the matrix? So the brute force approach which is coming into my mind, that just flatten the matrix into a linear data structure, let's say an array, and storing there, and just find the middle element. As we know the definition of median, it is the middle element. All right, so if we flatten this matrix, let's say in the brute force approach, what we can do, we can just iterate the whole matrix and store it into a data structure, let's say array, and then apply sorting. So after applying sorting here and storing it linearly in a vector or array, we get this array. All right, 1 2 3 3 5 6 6 9 9. And we all know that median is the middle element, so we can see find here that 5 is our median because exactly 4 elements are before 5 and 4 elements are after 5. All right, so 5 is our median, so our answer is also 5. But this will take extra x log x time complexity for sorting, and x is where the total number of elements n cross m, and an extra space also for storing them. So how we can think of solving this problem in a better approach? So we know that what we can observe here, that if anyhow I flatten this matrix and I find the middle element, that is 5 here, middle element. And what is the middle element? We know that how many elements are there in this entire uh, flattened or entire array, or how many elements are there. We can see that total n cross m elements are there, and for an element to be the median, we know that exactly n cross m by 2 elements, exactly n cross m by 2 elements should be before the median. I hope you understood that for an element, for being median, exactly n cross m by 2 elements should be before the median. And what is n cross m by 2 here? So n cross m is what? 3 cross 3, 9, and 9 by 2, you all know that is 4. So total 4 elements are there. So if we find any element whose left side exactly 4 elements are there, then we can guarantee say that this is median. Okay, this first observation we have noted. First observation we have noted. All right, that exactly n cross m by 2 elements should be before the median. Okay, now how we can proceed? So if what if how many elements are there? N cross m elements are there, and what is the range of the elements? So if range of the element, if I say that it range, we can say, is minimum to maximum element present in the array. All right, so how we find the minimum element present in the array? we know that all the rows are sorted. 135 is sorted, 269 is sorted, 369 is sorted. So it means that the first column, if we find the minimum of the first column, if we find the minimum of the first column, this will give minimum starting element. All right, this will give a starting element. And if we find the maximum of the last column, let's say zero based indexing is there, so this will be C2. Now if I find the maximum of the last column, this will be the ending element. So our range will be lying from the start to end, let's say. So what will be our range? Our range will be what? From start up to end. And starting, we all know that the minimum element present in this array, and ending range is maximum element present in this array. First way is to iterate all the matrices and just find minimum and maximum. Second way is that we all know that row wise they are already sorted. It means the minimum of the first column will give the starting element, and maximum of the last column will give us the maximum ending element. So okay, now we know that answer is between this range only, start and end. So what if I linearly try and go and try for let's say, what is the start here? Start is minimum of these, that is 1, that is 1. End is what? Maximum of these, that is 9. So we know that here the elements are ranging from 1 to 9. So what can I do? What if I check every element in the range? That okay, if I talk about 1, how many elements are before 1? So if we count, if we just call up, if we make a function, another function that will give us the count of how many elements are less than the our target element. So here our target is 1, let's say. So it will go in the array and find us how many elements are less than 1. So in the array we can see that no element is less than 1. So this will say that 0. Okay. Now again we will just go and try for 2. For 1, 0 elements were there. For 2 only 1 element. We can see here we have, so we can just take this reference also, that before 2 only 1 element is there, before 3 only 2 element is there, and before 4 only 4 elements are there. So we now we can see that we have to find exactly n minus n cross m by 2 elements before the median. So if I found any element who has exactly n cross m by 2 elements before the current target, let's say, we can say that is it our median. So here in this case I have found that before 4 exactly 4 elements are there. So does it mean that 4 is my median? It should be, because exactly n cross m by 2, that is 4 elements are before 4. But it can't be our median because it is not present in the array. Okay. So this is second observation, that if I am finding for every target from starting to ending range that any element, any target, number of count of elements, let's say, who are less than the target element, agar if they are equal to n cross m by 2, we will say that it is our median. But it is not true always, because maybe any element, because what we are doing, we are going from start to end, and start to end is containing all the elements from start to end, but not necessarily all the elements from 1 to 9 are present. We are just assuming, we are just taking a range, we are just assuming range. Start element is 1, ending element is 9, and we are just checking for each and every digits, and if any and we are just calling a function that will give us how many elements are before this target, and if it is equal to n cross m by 2, we can say that this can be our answer, but not necessarily this is our answer, because maybe it is not present in the matrix. So what we should do, so we should not stop here. It means that we should not stop here, we should go forward. All right, so if I go and check for 5, so 5 also, all exactly we can see that 4 elements are before 5, and for 6 also we can see that exactly 5 elements are there. So we can in this case that we can see that if we go further, it will give answer greater than equal to 5 only. So we can see that 5 is our answer, but this is okay, but two problems are there. First of all, how we will write the function that will give that exactly these number of elements, exactly how many elements are there before any target. Let's say if I have to check how many elements are before 5, I cannot check. I can check, but it will take a very high time complexity. I have to iterate, I have to sort them, so that's not good. So we have to do something, but we have made our observation and we have made our intuition also that n cross m by 2 elements should be before the median. And now what observation observation 2 I have made at I can check from start to range. So instead of checking linearly 1 to 9, I can just use binary search, because my range is 1 to 9 and the elements are like 1 2 3 4 5 6 7 8 9. And now what I'm doing, I'm trying to check for each and every element linearly, but I can use binary search also. So that's why, first of all, what will be my start? I'm telling you again, what is my start? Start is 1. What is my ending? Ending is 9. And as we apply binary search, we will find mid, and start is 1, end is 9, and let's take low and high, because we are in habit of taking low and high. And mid is what? Mid is 9 plus 1 10 by 2, that is 5. Mid is coming 5. Now I want to check how many elements are less than 5. I cannot check it. I can check, but I have to again store all the elements somewhere and then sort them and then check how many elements are before 5. But I can definitely check how many elements are less than or equal to 5. How? We know that this is our array. All right, let me just copy this. We know that this is our array. This is our matrix. This is our matrix. And now I can check how many elements are less than the mid, but it will take very high complexity. But I can easily check how many elements are less than or equal to mid. How? See, every row is sorted. If I go to every row and apply upper bound, all right, if I apply upper bound is what? Upper bound gives if I give any target to in the function upper bound, it will point to the iterator, or we can say the index, the element which is greater than the target. All right, so upper bound will give the index of the element that is greater than target. So if I go to every row and find index of the element that is greater than 5, So in the first row it will give uh, in the first row it will go out of bound, but this will give me uh, if I find if I find we all know how to apply upper bound. In the upper bound function, if I write, if I go and find upper bound this matrix of 0 dot begin comma matrix of 0 dot end comma target is 5 minus matrix dot begin, so matrix of 0 dot begin, so this will give how many elements are less than or equal to 5. Because let's say if I am telling you, if I take the example, let's say I have to find, let's say my mid is 3. So in the first row it will point to the upper bound will point to the index which is greater than 3, so it will point to 5. So what is the index here? Index is 2 here. So this will, the index number which it will point will tell us how many elements are less than or equal to 5. All right, it will tell us the number of elements less than or equal to 5. So upper bound I am using because it will give me, first of all it will point to the element which is greater than target, and in this case if target is 3 it will point to 5, because 5 is just greater than 3, it will point to 5, and here the index number is 2. So upper bound will give this 2, it means that exactly 2 elements are less than or equal to 5. So I hope we all know upper bound. So upper bound will tell me how many elements are exactly less than or equal to 5. So okay, and now similarly I can just check for here also, here also, here also. So if I talk about the first that is mid, it will give me, if I maintain a count function, or I just create another function that will tell me, that will go to every row and apply upper bound and will count me how many elements are exactly less than or equal to 5, less than or equal to mid. So this will give me, so here in this case count will come what, from the first row exactly 3 elements are less than or equal to 5, and in the second row exactly 1 element, and the last row exactly 1 element. So 3, 4, 5. In the first case 5 will come. All right, so and what is our desired count? That for a median exactly n cross m by 2 elements should be before, but here we are able to find how many elements are less than or equal to 5. So if I talk about the desired count, earlier we were finding n cross m by 2 elements exactly before the median, but here our count function is giving us number of elements smaller than or equal to the target. So if I increase desired by 1, if I increase the desired by 1, n cross m by 2 plus 1, so this way what will happen? In this case n cross m by 2 was 4, and if I add 1 this will be 5. So it means that let me explain this also. So if I sort this, so if I find any element, let's say 5, if I talk about 5, how many elements are less than or equal to 5? So it should be, how many elements are less than or equal to 5? 5 elements are less than or equal to 5. So that's why I was increasing n cross m by 2 plus 1, because this will be including the current elements also. This will be helping in including this current element also. All right, due to our constraint that we are only able to count numbers less than or equal to target. All right, so instead of just taking desired count as n cross m by 2, I can just take desired count as n cross m by 2 plus 1 that will be 5. That will be 5. Now if whenever I will find any target that is giving the answer as n cross m by 2 plus 1, so I can say that this is my answer, this is my possible answer, this is my possible answer, and I have to check again and again. And this I can explain you also, that why not we are sure that let's say my target is 5 and I call the count function, it is telling me that exactly 5 elements are less than or equal to 5, then why we are not returning directly? Because maybe it's not our answer, as I told earlier also, maybe it's not present in the array. That's the only case. I explained you earlier also that what if we find the answer and it is not present in the matrix, it is not present in the matrix, so that's we will keep checking, and at last the low where it will be pointing, low and high we have two pointers, so the element low will be pointing will be our answer. And I can explain you that also, but let's dry run also. So in the starting low was 1, high was 9, mid came 5, and count function gave me 5 elements, and desired was also 5. So I can say that this can be our answer, this can be our answer. So according to binary search, this can be our answer. So if let's say our count came then less than desired, so what we do, we go forward. But in the else case, when count is greater than or equal to the desired element, what we do, we go backward. So in the backward case, what we always do, we apply high as mid minus 1, that is in this case we should say that answer is in the range 1 to 4. But no, we have seen here that count is 5 and desired is also 5, so we should also consider this 5 also in the range, and we should say that high initially was 9 and now high should be, if I have to check backward in the else case, I should say that my new range will be from low to high. Alright, now my new mid is 5 plus 1, that is 6, 6 by 2 is 3, so my new mid is 3. Now again I will just go and find that how many elements in this matrix are less than or equal to 3. So from the first row, number of elements less than or equal to 3 are 2, here 1, here 1. So 2, 3, 4, 4 count is coming 4, and it is less than the desired, so it means that our answer is lying forward, so we should move forward. And yes, I should move forward, and while moving forward, it means that mid is not our answer. So I will just say that check forward and make this low as mid plus 1, that is 4. Now again my new mid and new count will be counted. So 4 plus 5 is 9, and 9 by 2 is 4. So mid is 4. And count, if we count here, number of elements less than or equal to 4 in the first array, 2, second 1 and 1, again 4. So now again answer is coming less than desired, it means mid is not of my answer. Again if I have to move further forward, so I will say that low is now my mid plus 1. Alright, and now again my mid will be counted and low will be counted. Again my mid will be 5 and count will be what? Count will be, this will be 3, this will be 1, 1, and this will be 5. Now my desired is coming to equal to counted, and in the else case, if desired is greater than or equal to count, if count is greater than or equal to desired, we move forward. It means mid is my possible answer. Now again I have to check make my high equal to mid. So again I will check 5 to 5, and again it will cause infinite loop. So I can stop where, when I can stop when I can apply the in the while loop. I can say when low is less than high, then only move, otherwise don't move. So initially, if you remember, low was 4, and and we have to increase our low. All right. So when we will increase this to 5, and when we find that low is not less than high, and then we should return, then we should come out of loop and we should return low. So why low? Because low is pointing to the right answer. We can say that low is pointing to 5, and 5 is only our answer. And you can try it on your own also, and you will get all the answers of your problem. I also did the same way. It took me much time to understand this problem. I did dry run on every possible cases. I checked why I was doing low less than high only, why I am just finding less than equal to, why not less than, and why upper bound, why not lower bounds. If you dry run on your own, you will get answers of all your problems. That's the key. uh, I also think that it will take time to dry run on my own, but this works and it's worth it. So in every case you can see that low will be pointing to our answer only. All right, in every time we can see that low will be pointing to our answer. So, and that's why we were increasing low also, because let's say 3 5s are there, and for every 5 we will get the same count. So that's why uh, if it's equal to, if the count is less than desired, we have to move forward. And that's why, let's say low is here and low will move forward. All right, and eventually low will come to the median. If we keep increasing low, eventually low will keep, come to median, and the time will come when low and high will be at the same point, or they will cross. But low will cross from median only, and before crossing the median, uh, we stop low less than high, and eventually we can see that low is on our median, and that's why we return low. And I hope you understood, and otherwise you can dry run on your own also, and it's the very best thing to dry run. And if I go and just implement it, so first of all I will find the size of the matrix, that is mat.size, and n cross m matrix is there. So n is what, m is mat of 0.size. Now what I was doing, first of all I have to find the starting element. So a starting element, or low, or start, whatever we say, I'm using binary search, that's why I'm saying that low. So initially low will be what, low I have to find the minimum. So I'm saying that low will be int max and high will be int minimum. And now from the matrix, I will go to column number 1 first. I will go to every row and I will find my minimum element. I will go in the column 1. So low will be what, minimum of low comma matrix of column 1. Row is changing and column 1 will be 0. And similarly high also I will find from the last row, from the last column, that my high will be what, maximum of high and matrix of I comma last column is m minus 1. Now my range is ready from low to high. and while I will apply binary search while low is less than high. First of all, obviously mid I will find. For finding mid, we all know low plus high minus low by 2. For just we can also say that high plus low by 2, but this can save our edge case also at int max and int min case. At that case also, this is also the way. You can just check on GFG or any another platform also, and if you will ask me, I will explain it also. Now, for after finding mid, what we have to do, what I was checking first. For every target, mid is my target. For every target, I will call a function count that will tell me how many elements in the matrix are less than or equal to the target. So I can just call a function how many elements are less than or equal to smaller equal. This is an aesthetic name, so I'm taking it. So my target is mid. So my target is mid. Matrix I will send, and for just I'm sending also n and m. Now after I find count, and yes, what's my desired? Desired is n cross m by 2 plus 1, and if let's say my count came less than desired, I will go and check forward. Alright, and in the else case, when mid target maybe my answer target may be equal to desired, so that's why I'm considering mid also in the range. And at last we can see that low will eventually point to median when this while loop will break. Alright, because every time we are increasing it and we are stopping whenever this low is less than high. Whenever it is low greater than equal to high, we are breaking the loop. So eventually my low will come to the median. So I will say that return low, and I have to just write the count function. Very easy count function, we all know. So I'm just copying this, and this is my target, and this is my matrix. And now what I have to do, let's say initially my count is 0, and for every row I will go from int I is equals to 0, I is less than n, plus plus I. For every row, what I will do, I will just call the upper bound function. We all know upper bound function. So here I will send this matrix of I dot begin comma matrix of I dot end, and the target which we want to find, and matrix of I will matrix of I dot begin, and after finding the count I will just return the count. And now this way we can see we are done also, and if I check, we haven't made any silly mistake, so this will point us after compiling it. And if I submit it, let's check if we are able to pass all the test cases or not. So some error we are making anywhere. So now by mistake we have written here m in place of n, and if I now submit this and check whether we are able to pass all the test cases or not. So now we can see that we are able to pass all the test cases, and we have solved this problem successfully now. And if I tell you the time and space complexity, so we can see that time complexity is what? We are using binary search from the range start to end. So obviously, first of all, this will be what? Uh, Log of the range, and we all know what is the range. Range is from starting to ending. So range is what? Maximum minus minimum element. That is the range. All right. Into, wait, I should make space here. Into what? Into, and for every binary search we are using this count function also, that is going for every row and applying upper bound. So for every row it is going, so this will be n cross log of, and upper bound is applying to just the whole row, and size of all the rows is equal to the column. So we can see that total time complexity is coming log of range, that is maximum minus minimum elements, into n into log m, and space complexity, we can see that we are here not using any space, we are just using some variables and using just binary search. So this will be big O of space complexity is big O of 1, and time complexity is big O of log of range into n into log m. So this was all about this problem. I hope you understood. Till then, keep learning and keep upgrading yourself. See you in the next video.